Hello everyone, welcome back to my channel. Today let's go over a Leetcode hard question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any help. So let's go over it and let me show you how I did it. So this is 2642 design graph with shortest path calculator. So you're given a directed graph and basically you're given this matrix of edges where you have the from node, the to node, and the cost to go from the from to the to. And then you have this n parameter. So let's go ahead and initialize in the constructor what we're given. And because we're going to want to go from to, let's go ahead and make a dictionary to keep track of the key as each node, right? So for the from, the to, so for the node or source, destination, and the cost in the edges, then we're just going to append to the source node's key, because they're all integers, we're going to append the destination node and then the cost to go from the source to the destination here. Okay, so now basically, we want to do the same thing by adding an edge in this method. So this is just one list. It's not a matrix. So we're just going to say self.d of edge 0 dot append edge 1, edge 2. So the same way. And then to get the shortest path, basically, this is just classic Dijkstra's, right? So we're going to define a heap. Let's call this Q actually. And let's go ahead and print our self.d in node 1 and node 2. And let's just return a dummy value for now. So you can see to go from 3 to 2, we're going to get a shortest path of 6 because to go from 3 to 0 costs 3. So we're at 3 total. And then to go from 0 to 1 costs another 2. So that's 5 in total. And then from 1 back to 2 costs 1. So the other path, this one would be 8, so that would not be the best answer. So the idea here is to use a minimum heap, and we're going to append the source node that we're starting from, and then a cost of 0, because, again, there's no cost. We're going to get the shortest path when we do this optimally. And then let's also define a set called scene, and let's just keep running the breadth first search while the queue is not empty, right? So we're going to get the, let's call this the cost, and let's put that there because, again, we're going to want the minimum cost. So we're going to try to order by this index, not the node by itself, because they're all integers. And then we're just going to say heapify Q. Cool. So now let's get the cost and the current node. And that's just going to be Q or heap pop from Q. And let's print cost and node. So we start from 3 and we're looking at node 0 with a cost of 3. So basically we're just going to say if the node is in scene, then we can just continue. Otherwise, we're just going to add the node. So we don't have an infinite loop. And then we're just going to explore the neighbors of the current node that we're visiting, right? So if we're visiting 0, then we're just going to explore 0's neighbors. And the min heap is going to ensure that the cost it's sorted by the actual cost, right? So in this case, that would be this one. So the way we've ordered it will take care of that. So basically, we're just going to append or heap q dot heap push into our queue. We're going to want the cost, which is just going to be neighbor of 0 in this case, and then neighbor of 1. And let's just go ahead and print this. Okay, so you can see we get 6 here. And then 0 to 3, it looks like we can't visit from 0 to 3 because there's no leading node that lands on 3. So we just return -1 for that. And then here we also get 6. So if we're going to go from node 0 to 3, 0, again, 3, so we get 2, and then, so 3 plus 2 is 5, and then basically we just have to keep adding the cost. 5 plus 1 is 6, so we're at our, so 0 to 3, let's go over that example. For example, if we're starting at, so we're going to go to either one of these nodes, right? So we're going to explore 1 first. So we're at a cost of 2, and then after that, we are going to explore node 3 with a cost of 4, so that's 6 in total. So we've already reached 3, so that is the minimum path. And we're just going to append the cost plus the neighbor of 1. So if the node is equal to node 2, which is our destination, then let's print the cost, and let's go ahead and record that solution. So it looks not correct here. So we're heapifying, and then we're popping from it. And let's go ahead and print the queue. Oh, yeah. So let's print the queue. And let's print the cost, but that's not being set. So, oh, we ordered these the wrong way. So let's do it like this instead. DST. Okay, so the node and then the actual cost. So I don't think this needs to be reordered because, again, as I said, the minimum heap will take care of that. So going down here, let's print cost and node. So cost and node. So we're trying to go to node 2. And we're going to make sure that we don't have duplicates. So we're exploring all this node's neighbors, and we're pushing the so if we're exploring this and then we have it like that, let's actually push this plus neighbor of 0. I think that would make more sense. So let us try, let's go ahead and see. So from 3 to 2, we're going to explore 3, 0. That's not correct. We're going to add neighbor of 1 as before because that is what we have. And then we're going to add the node. Yep. So what is going on? So if the node is equal to node 2, again, we're starting at node 1 and we have that. But I don't see that we're printing this. Oh, we got this messed up, I think. So node cost. So we're appending it like this. Let's go ahead and just do it the other way. So node and cost. Okay, so now we can at least see what we're working with. So, okay, cool. So now you can see this is sorted in by this, and then we get 6 at the end. Cool. So let's go ahead and report the answer. If we're at the destination node, the current cost, because that's going to be the minimum because of the heap. So return self.answer at the end, right? So if self.answer is not equal to -1, else -1, or not equal to math.infinity because we're trying to minimize it. Okay, so now, again, we need to sort it by, we're not sorting by the right thing, because you can see this is bigger than this, so we just need to push. So let's do this. Let's do 0 and then node 1. Let's reverse it again. And node, cost and node. If node isn't seen, yep. And then here we can append cost plus neighbor of 1 and then neighbor of 0 here, right? Okay. Okay, so let's submit it. Okay, output limit exceeded. Do it again. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for question 2642, and thank you for watching.